So on page 415, we talk about a pinhole camera. We just watched this video here, and it'll be on the website if you want to take a look at that again. We might be constructing a pinhole camera of our own to view objects at a distance outside, especially from this classroom would be really good because we have a view of lots of trees and buildings and different things from the windows, also from the windows of the science lab. So yeah, these would be good to build and to test from even indoors if it's still cold when we get there. Yep.
If you put a piece of film over it, like camera film,
Yeah.
and then cover the light, and then like
Yeah, if you
only exposed it.
Yeah, it would probably not work if this was camera film, like old style camera film, because there would be way too much light that would get in there. It would just flood it. It would just be all white. But if you were, I mean, that's how cameras work, though, besides the fact that they have lenses and mirrors and stuff. But the old style cameras, they have like a photosensitive, light sensitive film, and the light at different frequencies, at different colors and different shapes, as it impacts really briefly, really quickly, the film, then it would record a picture. You could develop that and get a picture. Yeah, that's how it works. With this one, I don't think that would work so well because even getting the film on there, like how would you get the film on there without exposing it to light? You couldn't really. So, but with the tissue paper here, as in the construction, you would probably be able to see an image. Now, I have / had one. I think it maybe is lost or destroyed, but I had one for an example, and it didn't work real well. But you could see, I think because it got deteriorated pretty quick. But yeah, so we might be putting this together. I would encourage you to find some plastic or some kind of cylinder containers. It doesn't have to be tin or anything. It could be like a Pringles chip box, or it could be a soup can, or it could be any kind of cylindrical container. And if you could find two where one slides into the other, that's the kind of the beginning of this pinhole camera. So keep your eye open for that this week. At the end of the week, we might be building this. But what can we learn from a pinhole camera? We can learn a couple things. Shh, quiet now, guys. Light travels in straight lines, okay? Now, if we are in the same medium, like if it's air from beginning to end, if it's in the pool, if it's in space or whatever, wherever we are, as long as the medium doesn't change, then the light will travel in straight lines, okay? This is called linear propagation. Linear propagation. So linear means straight line. Propagation means how it is projected or propagated, okay? How it travels. And so light beams travel in a straight line. A beam of light is a stream of light rays, okay? So just, what's a beam? Well, a beam would be a stream of light rays. So we're talking about a collection of many light rays in a beam of light. I mean, I don't know if we need to explain that, but the stream of rays can be converging, parallel, or diverging. So light traveling in a straight line, obviously light traveling from an object goes in all different directions, right? It bounces off the object. Some of the light gets absorbed, and some of the light gets reflected. And that's why we see different colors, actually. That's why you can differentiate between colors, is because some of the frequencies of white light are being absorbed and some are being reflected. And so I can see different colors of what you're wearing because the white light that is coming from either the lights or outside, some of it's being absorbed by the dyes or the material in your clothes. And so we only see the colors or the parts of the white light that actually reflected back. Cool. There's lots of study you can do on light and color and things like that, which we'll get into a little bit. But as in the video, light rays that are coming, let's say if we just focus on the light rays that are coming from the top of the tree here, okay, those light rays are going in all different directions, aren't they? All different directions. But one of the rays of light that we would see coming through this small hole in the pinhole camera would just sneak through here and would impact the screen down here. So again, light travels in straight lines, and this beam of light that we would see would impact the screen right here. Question, boys? Okay.
Does our brain and our eyes work the same way? Like
I can't hear you.
Wouldn't the image be good for our eyes?
We're getting there. We're getting there. So from the bottom of the object, okay, light rays again are traveling in all different directions, up, down, sideways. But the one beam of light that we would be able to collect through this little pinhole here would come and impact the screen on the opposite side. So that's where you get this inverted image. it's not like the light rays. Okay, so they don't do this. You don't have light rays coming from the top of the tree and then sneaking through here and then going in different directions. They don't bend up, they don't bend down like this. Okay? So just to pause for a second, I'm going to just wrap up here. Just to answer your question, your thought there about the eye, that's exactly what happens in our eye because our pupil is a very small opening that only allows certain beams of light in from objects outside, right? So we have an inverted image on the back of our retina, and our brain flips that around so that we see things, the way we see them. But yes, the images on our retina would be inverted and upside down. So we'll talk a little bit more about the pinhole camera tomorrow. As we continue, please have those 2 questions finished.